We have determined this function in the previous video. It allows us to distinguish between prime and non-prime numbers, as it inputs 1 if the input is prime and 0 otherwise. It may sound cool on paper, but practically this function has significant drawbacks. First, it becomes very cumbersome very quickly. In fact, imagine calculating the greatest common divisors of all the integers less than a certain n. For n equal to 5, it's doable, sure. N equal to 10, still doable. 15, yeah. But then when we go to 20, 25, 30, 50, 100, do you imagine calculating hundreds greatest common divisors? That's a lot. And by hand, it is practically impossible. So this function is not practical. It can become cumbersome very fast, and it is tiring to use manually. Another limitation is that it is quite redundant. In fact, when you are calculating the sum of the greatest common divisors, from the results you get, it is possible to determine what the output of the function will be without doing this quotient or rounding down this quotient altogether. Why? To see why, take for example n equal to 8, for example, n equal to 8. I calculate greatest common divisor. 7 and 8, it gives me 1. Then 6 and 8, it gives me 2. At that point, since 2 is strictly greater than 1, I already know for a fact that 8 is not prime, and therefore k of 8 equal to 0. So why go through all the struggle of calculating the greatest common divisors of 6, of 5 and 8, 4 and 8, 3 and 8, 2 and 8, 1 and 8, and then making a division and then rounding down all together? That's redundant, because we could already predict the results from when we had calculating the greatest common divisors. So yeah, it is not elegant in mathematics to work with functions that can be quite redundant. So it's a drawback of this function k of n to keep in mind. And lastly, you might want to go to the computer route, since you have shown that the function is not really practical to use by hand. It's not really practical to use this function. Therefore, you may try to model it in a computer program. But if you know a little about programming, you know that there are much easier way to determine whether a number is prime or not using a computer program. You don't have to go to calculate all the greatest common divisor of all these numbers. You can just insert an if statement somewhere that indicates that if just one greatest common divisor is strictly greater than 1, then it breaks the loop and it returns 0, because at that point you are sure that the input is not prime. Therefore, modeling this function takes computationally much more time and also much more memory. So these were 3 limitations of this function. But still, what I really appreciate about this function is this part here. Really, the fact that it inputs 1 where the number is from 0 otherwise, to me, it's just interesting. It's like it functions like a detector or an indicator of the primality of integers, and just be able to write k of a number or an expression or any integer equal to just 1 or 0 is, to me, quite appealing. But unfortunately, as you have seen, it is truly not practical and convenient to use, be it manually or computationally. So we need to think about improvements. How can we improve this function? How can we make it more practical, more usable? Maybe we have, maybe even to change. To make this function, we started to think about the greatest common divisors. Maybe we should start to think about something else. Maybe there's something we can change here, something we can adapt to make this function more usable. As simple as that. So what is it? Maybe we should redesign the function altogether and think about a new way to approach the primality of an integer. If, for example, you know another function that's able to produce 1 when the integer is from a 0 otherwise, feel free to share. Or if you have any idea on how to make this function better as a whole, feel free to share too.